Hi, I'm Jerry, Senior Application Engineer from Controller Service and Sales. Controller Service and Sales is a family-owned and operated business since 1926. We have two locations, Avon, Massachusetts and Providence, Rhode Island. Both locations are distribution and engineering services as well as training. We're a distributor for motor control products, automation, and networking. Today, I'm going to be focusing in on the Moxa Router, specifically one-to-one NAT. I'll get into that in further detail in one moment. This here is the Moxa EDR-810-G902. The EDR-G902 has a wide area network, which is called a WAN, and a local area network called a LAN. We have EDR-G903, which is a very fast router. If you have problems, if you need help with video or other high-speed applications, that would be the perfect product. That would have two WANs, which could be redundant WAN ports, and a LAN port. Over here, and I'll get into this in further detail in a moment, is the Moxa EDR-810-VPN-2GSFP. There's both a router and a layer 2 switch. The importance of this I will get into further detail as I mentioned in just a moment. But let's get into the network and show you the details of what we are setting up here for one-to-one NAT. Here we have the Moxa EDR-810-VPN-2GSFP. This device, as I mentioned, is both a router and a managed switch that gives you layer 3 and layer 2 functionality. Over here we have an IDEC PLC. This is the FC6A+, which also has Modbus TCP communications. Over here I have a Moxa ioLogik E1200. This happens to be a 16-point digital input remote I/O device. The Moxa ioLogik, as a closer view, has two Ethernet ports on board, so you can daisy chain other products. Also, power connection is on top, as well as all your connections on the front. This is your indications for power and what ports are being used and whether or not the device is ready. As you can see here, we do have flashing lights on here showing that we do have communications, and the layout is set up for one-to-one NAT. As I mentioned, Moxa routers have NAT functionality. What does that mean? There are three modes to NAT. One-to-one NAT, which is bi-directional, which means that I can request information from the wide area network, which is where the PLC is connected, to the local area network where my Moxa Remote I/O is connected. I can also request information from my local area network from my Moxa Remote I/O through the router to the wide area network to my IDEC PLC. Another NAT mode is port forwarding. Port forwarding would request information from outside the network, meaning the wide area network, request information inside the network, and return that information back to the outside of the network. The third NAT mode would be end-to-one NAT. That would mean on the local area side, we would request information from the local area side out through the wide area network and return the information back again. Think about your home network or your office network. If this was a PC with a browser looking for information out on the web, you'd be requesting the information out through the WAN and return the information back to the LAN. Let's get into the setup and how this is actually working. Let me go over the network structure again of what we have. We have the Moxa router. On the WAN port, we have our IDEC PLC, which is communicating Modbus TCP, which is an Ethernet protocol. We have our Moxa ioLogik connected to our local area network on our router. Again, that talks Modbus TCP. We can also communicate Ethernet IP as well. Right now, this is configured for one-to-one NAT. So as I mentioned before, this is bi-directional. So if you can see the indicator lights here in the output of the IDEC PLC, if I was to close this push button, which is a maintain button, you'll notice that the output lights will begin when I turn on or stop my logic. So I press the button and my output indicator lights are changing based upon the logic. Again, I can stop that logic by pressing this button. Here's a setup for the Moxa EDR-810 router. You'll notice that the WAN port is lit up in red, and all of my LAN ports, the local area networks, are lit up in green. My PLC is connected to the WAN port, and my ioLogik is connected to the LAN port. I'll get into the settings of this just in a moment, but let me show you the layout of the network and how that's all connected. There are several ways to communicate to Moxa products. This is MXconfig. It is a free utility from Moxa. Right now, I'm just going to go and look for my router product by doing a broadcast search. This will also work if you're on a different subnet or a different network. You can see that the Moxa router appears. I can either go in here and start editing. I can right click and do different settings with this, or I can go ahead and open up my web browser. Type in the default information. Again, for security purposes, you will want to change what your default password is. Moxa is prompting us to change the password, but we're not going to do it at this time. I can go through the quick setup profile and set up which ports are my WAN ports. Again, I can add multiple WANs or choose a different WAN port if I wish. On the network, I set up a static IP address for the WAN port. This is the WAN port address of the network. This is my subnet mask for the WAN port. That would be the address of whatever your customer will assign to you. This is my local area network. Notice that the local area network is different from the wide area network. Again, this is my subnet mask here as well too. To set up NAT, very simply, go into the NAT settings. Here I created a name for the one-to-one NAT, which you can see listed here. We can have up to 128 devices connected here. It can either be set up for one-to-one NAT, which is what we're doing here, end-to-one, or port forwarding, as I mentioned earlier. Also, you can choose how you want to have your network configured. This address here is an unused address on the wide area network. So when my PLC goes to communicate to the remote ioLogiks, I need to be able to access this address. The actual address of the Moxa ioLogik is 192.168.127.11. Network address translation will see the 10.10.20. We'll take that out of the packet and convert that to 192.168.127.11 and talk directly to the device. When the information is being returned back again, the router will then take the 192.168.127.11 off at the packet and insert 10.10.10.20 and then send that back out to the PLC. Here is the setup for the Moxa ioLogik. Moxa's free utility ioSearch will allow us to go out and search for our ioLogik product. I could also go to the web console and open this information up as well. Under user-defined Modbus addressing, I can go in and make some changes or adjustments, but using the default addressing, since it's a 16-point digital I/O product, you'll notice that digital value, which starts at address 0 for my digital input 0 through digital input 15. We're doing input status under function code 2, and our starting address is 10001. Total bits, 16 bits. There's other information here as well too, but for what we're dealing with, all we're focusing on is this one address here. Let me show you the setup on the IDEC PLC. In the IDEC PLC, you will note that the IDEC PLC is on the same subnet as the WAN network. Here we have 10.10.10.50. Again, that subnet mask is 255.255.255. Modbus client was set up to communicate to the Moxa ioLogik. Here you'll see that the client, which is the ioLogik, is set to 10.10.10.20. The same address that we have in our network address translation table. 502 is a default Modbus TCP port and will not change. Here you'll notice that we have our address that we had set up in the ioLogik itself. You'll notice that the ioLogik address is set to 192.168.127.11. We have a subnet mask of 255.255.255.0, and you'll notice that we have a gateway address of 192.168.127.254. That address is required because you can look at the router as being a traffic cop. The traffic needs to find its way out of the network. This can be used also as a security function so that no other devices can access the wide area network or be accessed by the wide area network. If that address is not there, we cannot communicate to the ioLogiks. I want to thank you for watching this video, and I hope you found it informative. If you have any questions or if you wish to have any training, please do not hesitate to contact us at 508-513-1000, or you can contact us on the web at www.controllerservice.com. Thank you and have a great day.